Strike two. All right. So I just did an introduction of you know, teaching this in a way where you can get some meaning out of it, and that's why I shared. Oh, I gotta be careful on what's being said. So I gotta pause for a second. Good start. Oh, what in the son of a. All right. Okay. Here. So I shared these videos, and then I thought they were actually for me more so to kind of get a feel for what it is that we're doing. I mean, I could have done these notes Monday and just shoved some formulas in your face and said, just do it, and then this is what it means. So I do have an infinite amount of sadness inside my chest right now for the students that didn't do squat about watching any of these. I don't know what you're doing. When I told you Monday, I had all 5 of these videos, and then Monday, that's while other people were taking a quiz, watch these. And then I put these on Tuesday, or maybe by the time Monday, I put these other ones on here. Or that's what I think I watched during 6 hour when other people were making up Monday. Because what these 2 videos on the Tuesday calendar do is kind of give you um, like actually doing some tests and then exercising these confidence intervals. So if anyone watched that, you know what I'm talking about. Um, and then the guy this on this Tuesday, I think a college professor talks about how this is done like in engineering and all this other stuff. So it does have a lot of real world applications. And I'll talk about that as I, go through what Mrs. McGrath, wrote. This is her writing, all very nice, and then I'll fill in the formulas myself. But confidence intervals. This is today specifically when. What is that symbol for that letter up there that I just underlined? That's actually sigma, but what is it actually? Standard deviation of what? A sample or the whole population? That's the whole population. Remember, this is a parameter. A parameter is, I mean, I don't know how else to say it. It's when you get everything in the population tested, and then you can find the mean. That is not a statistic. A statistic is when you take a sample from a whole population and analyze data. So that's number one. Today's formula, you know the standard deviation of the population, which is not likely. If you watched my videos, not mine, the other people, if you only have a sample, you don't necessarily know the standard deviation of the actual whole population. They do say that, but that's what's happening today. So somehow that is known. We're going to do interval estimates. What we're trying to find is the range of values used to estimate what is this letter right here? What is that letter that I'm circling right now? Mu. What is mu? Mu is not a statistic, a parameter. It is the mean of the whole population if you could do that. So now let's talk about an example where you'd actually do a confidence interval. And then hopefully as you're writing this stuff down, okay, and then the rest of this is use the sample mean, add or subtract a margin of error. That's what we're going to end up doing today. That's what a confidence interval is. So say your sample mean is 12.4 and you have a margin of error of 2.1. Well, that means your margin of error is the mean plus that margin of error and the mean minus that margin of error. That's where your interval estimate falls as estimate. Said estimate. All right, and then we'll get meaning out of this when we actually do a question, at least a little bit. I don't know how much meaning we'll see. It's not a shot at you. It is just a weird, not weird. It's a little complicated, I guess. Okay, so let's as you're still writing, and then we'll actually get this figured out here. This is just like a skeleton note for level of confidence. But let's say you are a company that makes light bulbs, and this particular light bulb you make 1,000,000 of them. I really want to hammer this point down about a parameter and a statistic. You know, on a light bulb box, you probably don't know this because you don't buy them, but the light bulb boxes have how many hours that light bulb should last. Do you guys know that? Like lately, I think an LED or what's the other one? The other good one, a fluorescent, right? It's like I think one of them say 10,000 hours. I may be off on that, but that's a number I remember. Well, that's actually probably a statistic. All right, that's probably from a test that may or may not be what we're doing today, because the guy in the video talks about engineers would do this at a certain confidence level, what they could say these numbers are actually doing. So let's go back to those million light bulbs. How would that be a parameter to find out that it's 10,000 hours? How many light bulbs would I have to test? All of them. I would have to plug in all 1 million of them and then find out the mean length of time that those light bulbs last. But what happens at the end of the test? Your light bulbs are gone. And then what did that company just do? They made how much money? Zero. They actually made negative money because they had to the cost of making a million light bulbs. So what would they really do? They would take maybe 100 out of those million light bulbs randomly. And that's what we did earlier in the chat. Remember the random sampling idea? So that we randomly pick these things, and the randomization of what light bulbs you pick should make your statistics a little bit better, as opposed to picking the first 100. Blah, 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 blah. So you test those 100, and then from those 100, okay, then we come up with this 10,000 hours of how long all these. So when I plug in my light bulb, will it last 10,000 hours? Yes or no? More than likely what? More than likely not, because it would, it's either going to be a little bit above or a little bit below, but at least it's a ballpark figure. All right, so, all right, so what does this mean? And you're not going to get this till the end, but you did pick up your sheet, right? And actually take your other z-score sheet out, because I'm going to go between the two and correlate some numbers that are on both of them that you can use. Okay, and I do have our old standard normal distribution z-score sheet ready to go, but I don't have the new one to pull up here. Okay, so level of confidence is what we're going to ultimately get to, and hopefully went wrong one. Oh, did you ever get one, or are you taking a second one? Oh, I'm talking to you. Did you ever get one of those? Okay. All right, good talk. Wow, things little. Okay. Just asking a question. The proportion of all samples whose interval contains, what does that say again right there that I circled? Mu, the actual population mean. So what we're going to do, and you don't know what that means yet probably, and that's fine. What we're going to do is this area under the standard normal curve between these critical values, we're going to call Z star and negative Z star. Okay, and then just go through the schematics of how I find these numbers, and then what they mean when we actually do a real-world question. Okay, so this was the first video on Monday. This guy showed how to find these numbers, and these variables are a little bit different than what he says. But to find a 90% confidence interval, that means this area right here is 90% of the area right here. So now, what does that leave for these two outside areas then? 5 and 5, or a total of 10. Okay, so the first thing I'm going to do is, and that's all that this means, 1/2 of 1 minus whatever that confidence interval is in decimal format, then half of that. Because we know there's 10% left, that means this has to be 5 and 5. It's not rocket science. But here's the next thing. What I need is how far from the mean we are from here to here. So what is this number right here all the way from the end to here? What number is this? So we can look at our Z chart to see what that number is. What is this number right here? 0.9. Uh-oh, 6 hour doesn't get it. Okay, 0.95, right? Because this is 0.95 all the way to the right of the very beginning of the standard normal curve with only 5% left over on the right. So what we need to do now is go to this, and then I'll explain how, well, that's not right. This, and find a p-value of 0.95. And where is that? Oh, that's that one where it's in between, right? See that right here? 0.9495 and 0.9505, right? So what do we do about that? It's 1.645. Go to here. Okay, it did work, but now I have to. So my Z value for a 90% confidence interval is equal to that z value that puts us right here, and then the opposite of that would be over on this end. What was that again? 1 point what? 645? And this is a number that you're going to have to use in a formula I'm just going to throw at you. That I quite honestly, I tried to watch the videos to be able to derive it, but we don't need to worry about that. Okay, so what this is 1.645 deviations to the right and 1.65 deviations to the left. That's why that's called negative z-score. But all I need is what is that z number? How far away from the mean are we for a 90% confidence interval? Okay, I'm going to do one more, then I'll show you on the new sheet where this number actually exists. 0.95. So what does that mean? That means the middle. Got to erase all these values and maybe the circles. That means 0.95 is in the middle. I don't know what I'm doing. Sorry. What does that leave for the tails? 0.025. Or 5% left divided by 2, right? And then that's what that number means, 1/2 of 1 minus whatever the confidence interval is. All right? But what's this number? What's that number right here when I go all the way from here to here? Area left of a curve. Point, I got to get rid of this because now it's new. Point, anyone? Come on, 0.975. So 97.5% of the area is left of this line. But again, all I want is what is that standard deviation number? Okay, or how many deviations to the right of the mean am I? Same idea with standard normal curves. Go back to this. Oh, I do have it. Nice. Where's 0.975? What'd you get? 1.9. I'll be darned. It's perfect. 1.96. Okay, so that is that z value. So what we're 1.96 to the right and 1.96 to the left. So z equals 1.96. And now we're going to leave that sheet and go to the new one. Look at the new one. And I'm not going to show this online. Sorry, but when I get our calendar fit today, I'll put this on here. Look at, and again, you don't get to do this until you get the sheet and you actually open it. But look at the very bottom of our new sheet. Look at the confidence level. Look at 90%. Do you see it right at the bottom? What's the z number right above it when you go z across? What's the z number? 1.645. We already found it. Okay, so now there's where it exists on the new sheets. Look at the number above 95% confidence level. What does it say? 1.960. Going to sleep there? I'm going to sell an alarm clock / a put you to sleep clock. At night, all it does is play me teaching a math lesson, which puts people to sleep like immediately. And then in the morning, you can program a name, so you wake up to this. Brian! Because that's what I do in class, because that's what I have to do almost every day with you, Chief. It's going to be $1 million idea. Anyway, all right, so now a third. How about a 99% confidence interval? What's the number in front above that for a z number? 2.5. What is it? 76. Yeah, someone thought it was an 8 yet last hour. Okay, also, so that may not look so good there. Okay, so you can use the new sheet on these. And by the way, if you watch the videos, how many people watch those videos, by the way? Raise your hand. A couple? They talked about the most popular confidence interval. What is it? What's the most popular one that's used? 95. It's the one that gives you the most. I got to get down here and get one of my sheets that fell. Sorry. All right, climbing around in class here. All right, but these are the three most popular. The most popular of them all, though, is finding a 95% confidence interval. All right, and that's the one that from watching the video that they get the most data. It's the best, I guess, scenario. Now look at this. Find z star for an 86 confidence level. Can you use your new sheet? Yes or no? No. Why? What's not on there? There's no 86. So what do I have to use? My old sheet. So what do I have to do? I have to understand that this is 0.86. Oh, and by the way, I'm sorry. Look at the new sheet again. Look at the top and then pick 95%. I just wanted to get you to understand one tail, two tails. Do you see that all the way at the top? It says one tail above 95% is 0.025. Isn't that what we said? So there's 0.025% in one of the tails, there's 0.025 in the other. The two tails are 0.05. That's just showing that. Do you got that? Okay, so just something else to understand about the sheet. Now, back to this 86% confidence level. Find Z for it. Well, what does that leave for the tails? What does that leave for the tails? 0.07. So it's 0.07 here, 0.07 here. What does that make this? 0.93. And now I have to go to my old one because my new one does not have this information. So I have to go here and find the best guess for 0.93. Who's better, 0.9292 or 0.9306? 9306. Oh, and I should have said this in the other hour. This is why using this Z chart, you know this is now an estimate, right? Isn't this an estimate? I did not get this number perfectly. So blah, 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 blah. But 1.4, what does that end up being? 8? So this ends up being a Z of 1.48. Now, here's the formula where you need it. It's our margin of error that we were talking about up above. This is the formula that I'm not going to derive it. I think a couple of videos try to explain where these things come from, but I think there's a lot more to it to really get a firm grasp. So this is one of those times where you're going to have to just accept this at face value. And do you have to have it memorized? No. But I will tell you that when we have our test a week from this Friday, did you hear what I just said there? Tests from a week from this Friday. You will get a formula sheet, but you will get no labels on that formula sheet. So we're going to have to work on today or today and tomorrow. When do I use what formula? And I'm going to try to actually get you to understand that. I think first hour I told them a couple things. Last hour I had a couple internet problems that really screwed some stuff up. But the whole idea of getting that Z number is it's in this formula. All right, and it's some sort of multiplier that was, I think these charts are found from actually doing experiments. And then these numbers, or doing some computer algorithms or computer software gets these numbers through tests of things that fit under a standard normal curve. I honestly believe that. Times. All right. So this formula will stick out like a sore thumb, because what does that variable represent? What does that variable represent, by the way? Of who, though? This is the standard deviation of the population. I don't know why I've zoomed in so far. This is the standard deviation of the population, which is a parameter. And like, kind of piggybacking off of what one of the video people said, you're more than likely not going to know what that is. What we're going to do tomorrow is more used than what we're doing today, because you don't normally know the standard deviation of the whole population because you don't get to test the million light bulbs. You know what I'm saying? All right, but that's what today's formula sticks out like a sore thumb. You know the population standard deviation for some reason. All right, and that's the only thing I could say. Divided by the square root of n, n is the amount of trials. So back to our light bulb example, what would n be? Do you remember what I said? How many we tried? 100. We only tried 100 light bulbs to see what was going on. All right, and then Z is just what we call our critical value for this particular situation, whatever confidence interval you're trying to find. What is the corresponding Z score number? I guess is what we could say there. So our first example is just a formula usage, is all it is. Using a 95% confidence interval, n equals 54. What does n stand for? Amount of trials. And then what does this say? What is that? I know I kind of zoomed out, but what does that say? Standard deviation, which is sigma. But what 95% is your confidence number. What you need to find is your Z number that goes along with that, your critical value. What is it? Well, is that on our new sheet, so it's easy to find? Yes, and what is that number? 1.96. All right, and then you know what n is, and look, it's all there. So our margin of error is 1.96 times standard deviation divided by the square root of 54. Okay? Now, I know when I ask, hey, can you guys punch those numbers for me? I got it. Don't worry about it. Now, in relation to what does this mean with the question, we don't have any other numbers in this, so I really can't tell you what that means until we do the next thing. But this is what, I'm just going to stop there. We'll wait till the next example. This goes back to the beginning of the notes. What's an interval? What's an interval? Okay, well, here's what a confidence interval is. And I'm going to write this variable down, and you all tell me what that is. What is that? Sample mean. Got it first. Not the whole population mean. So this is the sample mean. So we took a sample. What is the mean of our 100 light bulbs? Plus or minus our previous formula, the margin of error. This is what we get to find. What is our then confidence interval, depending whatever that confidence level is, 90, 95, 99, which is the formula. So this is Z star times, this will stick out like a sore thumb because this is the population standard deviation. Tomorrow's, you will not know that. That's really the difference between the two notes. Tomorrow's notes will be a lot quicker than today's. Blah, 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 blah. So from the margin of error, you actually find a confidence interval for a particular set of values. Blah, 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 blah. This happens everywhere. Okay, so you read the question. Let's estimate the average age of all students enrolled. Sample of 40 students has a mean average of 20.9. So they actually find the mean average of the sample size. And by the way, the sample size is 40. I tested 40 students. So I'm reading along, and all I have to do is denote what are the variables that are given. A lot of people don't do that right when they do formula analysis or actually plug in numbers into a formula. Assume the population is a normal distribution. By the way, you can only do this stuff if the stuff is normally distributed. Okay, so I don't think that's something I said in the beginning. To do these confidence intervals, we just did normal distributions. So this has to be normally distributed. And then look, I don't know how they know this, but the standard deviation of the whole population is 1.5 years. So again, this really has to stick out like a sore thumb. They give you this. It should say the total population standard deviation is 1.5 years. We'll really try to make sure on the test that we have that designated. Construct a 90% confidence interval and then interpret the results. Now I'm going to zoom back a little bit, give me more space. So the confidence interval is 90%. What is the corresponding Z value? 1.645. And eventually this should be able to be something that you will remember. Sample mean is 20.9, the mean age of the students, plus or minus what's called the margin of error, which we just did in the last question. That comes from this magic multiplier for a 90% confidence interval times standard deviation, 1.5, divided by the square root of how many people you checked, which is 40. All right, and then I got to look at my sheet so we don't have to worry about doing the calculations ourselves. This is 20.9 plus or minus. This number in the box should be, what'd you get, 0.39? Okay, so those playing along, they actually got 0.39. Now, here's how you get your confidence interval and how you, quote, interpret it, which means how you write a sentence of what this means. 20.9 minus 3.9 is 20.51 less than, what variable is this? What variable is that a SAT attempt at anyway? Mu. 20.51 to 20.9 plus 0.39, which is 21.29. So notice we put a parameter in here, even though we don't know what this parameter is because we couldn't find this parameter unless we found the average age of every student at the school and actually did that. But this is what we can say now. We are 90% confident that the true, I should have wrote this in a different color, mean age mu, which remember what that means. That's the total population mean, which we don't really have an ability to find unless we actually found it, is between 20.9 and 21.29. And that's the statement that we say that's what this all does. 20.51. What did I just... No, 21.29. It's between... Oh, did I write that one wrong? Oh, you're right. I looked at that number wrong. I'm trying to look at too many things. All right, so even though we don't know the total population mean, we know that we are 90% confident that it'll fall between those two numbers. Kind of weird stuff, right? There's a reason why I'm grabbing this formula here. To try to help you on this meaning, so you know when to use this just by how a question is worded. I'm going to paste it over here to the right. All this formula that I'm going to write off to here for finding a minimal sample size, which will end up right here, is a reformulation of this formula. All it is taking this formula and solving for n. And then I'm going to use it for this and then try to describe what it actually did for you, which I'm not sure if it'll be all that great, but just take it to heart, but that's what this means. So how would I solve for n, my algebra students, those that were in CAT? We should know how to do this. What would I do first? I wouldn't divide by z maybe. Yeah, that might be a possibility, but actually I would probably try to get n out of the denominator, so I maybe would also what? Multiply by the square root of n both sides, right? And then I might leave z there, because now I got n on one side of the equation. I mean, and I can now isolate it. Now what would I do? Now what would I do again by itself? Divide by e, and then what would I do last? I would. What's the opposite of square rooting? Square. So n equals the quantity squared, z times standard deviation divided by e, the margin of error. Okay, so I don't know. I just thought I would do that because I knew that's where this formula came from. Again, this formula sticks out like a sore thumb because the population standard deviation is somehow known. That's what that number or that letter means. Again, trying to help you when to use what formula when it comes to the test a week from Friday. Okay, so you can read this question. Chef wants to estimate the average temperature of a restaurant kitchen. Good for him. The estimate must be within 0.5 degrees of the population mean. What variable is 0.5? Not sigma. Huh? Not z, so there's only one left on the right side. This is your margin of error. Maybe you forgot what E is. E represents error or margin of error of this situation. So again, usage of a formula is knowing what the numbers are in a word problem. And maybe you would have caught this if you thought this was the standard deviation, because assuming the population is normally distributed, this should be in every sentence. But if it's not, assume it, okay? With a standard deviation of 1.5 degrees, right? So 0.5 can't be a standard deviation, 1.5 is. Right? Determine the minimal sample size to construct a 99% confidence interval. Minimum you could do is, wait, okay, what am I doing? Well, he told me to use this formula. I have this, and then I eventually figured this out, I hope. So what's the only thing I need left? How do I find z from a confidence interval of 0.99? I look at my what? Chart. Is 99% on our second sheet? Yes or no? What is the number? 2.576, and now we could find n because we have all the quantities that we need. And then I'll write a sentence about what these things mean. What time is it, right, by the way? 44. I got plenty of time. 2.576 times the standard deviation number, 1.5, divided by E, which is a margin error of 0.5, and then I need to square it. And then what we end up getting, I just want to get the decimal, 59.675. That's what I got. Oh, no, I think it's a little bit off. What do you guys got? I think 7.2, sorry. All right, and then we should always round this up because we're not going to have a decimal kitchen here. So this is how many kitchens the chef should test to follow all of these parameters and make this happen. I don't know if that's going to give you a big feel for what this actually means. Honestly, if that didn't work for you, know how to use the formula. Know what variables are given, and then know how to label it again. A chef wants to estimate the average temperature of a restaurant kitchen. So he's testing kitchens. N represents the amount of kitchens he's testing. So that's what we have to come back to at the end and figure that out. All right, a little rough. And then the last one. This is more for tomorrow than today, but it also, look at your worksheet that you picked up right now. Look at number 13. You're going to want to do this for number 13. Number 13 is doing a confidence interval, but what do they give you instead of any information? They just give you what? How many numbers there are. What's N? What's N for number 13? Well, how many numbers there are, so you have to count. N is how many numbers there are. What else do you need for those numbers? Well, look at our formula. You need what for our margin of error? You need the mean. So what I'm going to do is show you how in your calculator you have your mean. I'm going to tell you tomorrow. Tomorrow you're going to have to find your sample standard deviation. You remember how hard that was? Remember how hard it was to find a sample standard deviation? You'd have to take the mean, take the x value minus the mean, square it, add them all up, and then, remember, and then divide by n minus 1. Remember all that stuff? Square root, I'm messing it up by trying to just talk about it real fast. So I'll show you how you can do this on your calculator real quick. How many people have an Inspire? Raise your hand, please. Inspire, you're going to have to follow along with my words. 4 and 84. Remember where we go? We hit stats, hit stat, which is right there, then edit. Now, as I talk to the 84, some problems they could run into. For Inspires, I believe you just open up a new document, and it's a list or spreadsheet, and you want to open up a list. Do you remember that? We actually did this in Discrete, guys. We actually put some numbers in lists. Okay, you guys can go ahead and put your Inspires in column A. You can put these numbers. Now, I already have the numbers up here, but how many people have L1 filled out already? Okay, what we want to do is clear. Don't delete. I'll show you what happens when I delete. I just delete L1 and it's gone. So what do I do now? Well, actually, I have to go back up to the top, which I already am, and insert L1 back and press enter. And my list is still there anyway. It did nothing. All it did is delete L1 out of there. So what you really want to do is clear and then enter. And now L1 is blank. Make sure you are in L1. A lot of people made some bad mistakes last hour of not putting this in L1, and then they screwed up their whole situation. Okay, 10, 12, 14, stimulating video here. The person just naming numbers. 19. All right. Now, okay, so my Inspires. You put that list. Now, you stay in that chart, Inspires. Now, what we're going to do is go, I'll just hit second quit. I'm just going to get out of this because we do have to do this on our main screen. For Inspires, stay in your chart and have all those numbers down in column A. For Inspires, hit menu. Inspires, hit menu. For us, we hit stats and then calculate. Now, for the Inspires that hit menu, I think it's something about statistics, or one variable statistics comes up right away, maybe? Okay, there you go. You're ready to go. The one thing you got to make sure is you do have your list in column A, and it says list is in column A with brackets. And then all the way down to the bottom, it says column B. That's just where it's going to put the answer. It's going to put what we get. Press enter on that. If you have an upgraded 84, you get this. If not, it just says, I think it calculates it. This just verifies in an upgraded. Did you put everything in L1? I did. And then I want to calculate. I don't know what frequency list, to be honest, is. Hey, look at the top. What's that top thing mean? What happened? We lost somebody. Okay, I'm gonna hit second quit. We lost someone. I'm gonna go offline for a second. Back on. What's that top thing mean? What's X line mean? Sample mean. Okay, and then these are other things that we've done throughout, but do you know what this stands for right here? That's sample standard deviation. We're going to need that for tomorrow. Today, we don't need that. Look at number 13. It gives you the population standard deviation. So again, it's one of those where it gives you the whole parameter, population standard deviation. That's the number you use in your formula. Tomorrow is all about when you don't get the population standard deviation. You have to use the sample standard deviation, so that exists right there. Not here. What does that symbol imply, which I don't get how the calculator is doing this anyway? What does that symbol imply right there? That's the population. How could that possibly be when you don't know anything about the population? So that I don't get. I'd have to ask someone that knows a lot more than me. I know we don't use that. We use this tomorrow. So doesn't number 13 tell you the population standard deviation? Yeah, so that's why you ignore this number. Tomorrow we're going to be dealing with that as well. But for today, do number 13, find the sample mean through that, and then we could go from there. But that's the sample mean for this. So the sample mean is 12.14. And then the sample standard deviation really doesn't apply to today. This is what we're going to have to do tomorrow. But this is where it exists in the calculator. S right there, 4.56. Okay? All right? And then we'll just leave it at that. We're done.